Alright, so we're going to look at our vocabulary for Unit 1, and we start with the quadratic equation. So, a quadratic equation is going to be this. 0 equals ax squared plus bx plus c. This has only one condition with it, and that is a cannot equal 0. Okay, so we have to have a squared term. We can't have 0x squared. So we've got to have at least one. We don't need any x's, and we don't need any constants. That's what we need. So we're going to be working with this a lot, but that's what an equation is. Now we're going to move along to, hey, what's a real number? So a real number is almost any number you can think, almost any number you can type into a calculator. They have no complex parts. Or excuse me, not no complex parts. We have no eyes. So no imaginary parts. So that's going to be the simplest thing for you. So these are actual, tangible numbers that you can say. They can be irrational, they can be non-ending. So it means, like some examples, it's almost everything. The number 1. The square root of 2. That never ends, but it's still a real number. Pi, they're made up of all digits that we know and no imaginary parts. So anything you can think of, negative numbers, 0, whatever, as long as there's no eyes, that's what a real number is. Now if we move down to what a root is. So a root is the bottom of an equation where our variable equals something that makes it true. So a root might be something like x equals 1, x equals 0, x equals 3, etc. So these are all different roots. They are values that satisfy an equation, and that's it. So that's what we talk about when we talk about a root. The very bottom, the very end of solving an equation has to do with the roots. Now, we use the roots to build things later, and we always want to find roots. So if you ever are asked to solve, we're looking for roots. Okay, so then we see, well, what about equal roots? Well, equal roots are going to be where you have two roots that are the same. So let's say, for instance, we have an equation like, let's say, x squared equals 0. Okay, well, x squared equaling 0 has two roots. So we can separate this. You can think of this like x times x equals 0. Well, either x equals 0 or x equals 0. They're the same answer. And it's important to understand what equal roots mean. So we do have just one value that works. 0 is the only thing that works with this equation, but it happens twice. So it occurs twice, and that is special, and that's worth noting because it's a part of math. So make sure, in equal roots, you could have 3 equal roots, or 4 equal roots, or 5, or any number of equal roots. Now, they're going to also use this term distinct. So distinct means basically that they stand apart from each other. So we could have an equation like, let's say, x squared equals 1. Okay, so this is a little different. So what happens if x squared equals 1? Well, one way to solve this, and I'm going to solve this pretty quickly, is to kind of think about this in terms of factoring. So factoring, we like to move everything to the same side. And we end up with 2 factors. If we do this, we're going to have x plus 1 times x minus 1 equals 0. And so we're left with x is going to equal either negative 1 or positive 1. 2 separate values that work. These are distinct from each other. Negative 1 and 1 aren't the same. Now that looks different on a graph than, let's say, the other one. So the top one, we factored as x times x equals 0. We got 2 of the same roots. This one we had different roots because of the way that it factored. But basically, when you get down to your roots, if they're the same, then they're equal. If they're not the same, then they're distinct. Okay, so a discriminant. this goes back to our quadratic equation. So our quadratic equation that we had earlier was 0 equals ax squared plus bx plus c. Remember, we said that a could not equal 0. Well, the discriminant is the following. It is b squared, so the constant b squared minus 4ac. That is what our discriminant is. This little expression here tells us a lot about what's going on with a quadratic equation. It's going to tell us what kind of roots we have. It's not going to tell us what those roots are, but it's going to take us pretty close. Now, this discriminant also contributes to the very famous quadratic formula, which you all may or may not remember. And the quadratic formula looks like this, that if we have an equation, let's say, if ax squared plus bx plus c equals 0, then x is going to take on the following values. Negative b plus or minus the square root of our discriminant, which is b squared minus 4ac. I want to note that the discriminant by itself doesn't have the square root. We actually take the square root of the discriminant in the quadratic formula. And then lastly, we divide by 2a, that entire part. So all of these things get used at different points in time. So I want to make sure we go over those pretty quickly in a very concise way so that we understand what's going on. So all of these things do tie together very well. So quick recap. A quadratic equation, we have a quadratic part and then it equals 0. That's where we want to get it to. It may not start that way, but that's where we want it. And remember, a cannot be 0. Real numbers are ones without imaginary components, and we'll get to that in a little while. Roots are getting a quadratic equation or getting any equation down to the basis of the variable equaling a number or an imaginary number or something. We can have equal roots where we have 2 roots or more of the same value. We could have distinct roots where we have they're different values. And parts of the quadratic formula that we need to know are the discriminant and then obviously the whole formula. The discriminant can be used, and you should find the discriminant before you do any of the quadratic formula, because it can actually keep you from doing too much work. And it does tell you information that would be very handy.